Today is our first day of unit circle, and I'd like to focus specifically on the first quadrant of the unit circle, and then also the quadrantal angles as we go around. As you're looking at these diagrams that I have of the unit circle, you should notice the 30, 60, 90, and the 45, 45, 90 triangles, which are familiar to you already as special right triangles. The 30, 60, 90 can be calculated using a proportion of the sides. Know where the 30-degree angle is. That is our shortest side, and that will be our 1. The hypotenuse is 2, and the side across from the 60 is square root of 3. Since we're talking about a unit circle, what that is telling us is that the radius of this circle is 1 unit. So anywhere on this circle, I can go from the center to the side, and it's going to have a measurement of 1. If I know this, and I know my central angle is 30, I can calculate these other two sides using this proportion. If you remember, when they've given us the hypotenuse, we always return back to the side across from the 30, and we do that by dividing by 2. So, since they gave me the hypotenuse, 1, if I want to return to the side across from the 30, I would divide by 2, and that's how I get this 1/2. Once you're at the side across from the 30, you can go to the other side by multiplication. What are you going to multiply? You'll multiply by the square root of 3. So if I take 1/2 and multiply times the square root of 3, I get square root of 3 over 2. Now, these measurements that I have found are not only the sides of this triangle, they are also the coordinates of the x and y. The side that is on the x-axis gives me the value of x, and the height of my triangle gives me the value of y. Now, why is this important? When we're trying to solve for cosine and sine, cosine is the x value. Sine is your y value. So the way that you would typically see a problem set up for this, it would be focusing on this inner angle, this reference angle, and they would say, what is the cosine of 30 degrees? So what they're asking you is, what is the value of cosine at 30 degrees? You would look here. The x value, the x coordinate, would be the answer to your problem. So sine of 30 degrees would be the y value, 1/2. Now let's look at the next angle that you'll find in your unit circle, the 45-degree angle. As far as the proportion of the sides, we know that a 45, 45, 90 has a proportion of 1, 1, square root of 2. Again, I know the hypotenuse of this triangle because this is a unit circle, and so the hypotenuse represents the radius. It's 1. Since they've given me the hypotenuse and I want to return to one of the sides, I'll use division. I'm going to divide by square root of 2. If I take 1 and I divide by the square root of 2, I have an improper fraction. I cannot have a radical in the denominator. So I'll rationalize by multiplying the denominator and the numerator by the square root of 2. That gives me square root of 2 over 2. Both sides of the 45, 45, 90 triangle are equal to each other. So both sides are square root of 2 over 2. That means that my coordinate is the same for both the cosine and the sine. Now let's talk about the final angle degree that you'll see in the first quadrant of your unit circle. It's a 60. It's going to have the same answers as the 30, but you'll notice that they're in different locations because now your short side is on the x-axis and this longer side is your y measurement. Just like before, my hypotenuse is still a 1. So if I want to go from the hypotenuse to the short side, I divide by 2. That gives me 1/2. To get from the side across from the 30, I'll multiply by square root of 3, and that gives me square root of 3 over 2. So this time, my x value is 1/2, my y is square root of 3 over 2, which means my cosine is 1/2, and my sine is square root of 3 over 2. Now before I move on, I want to remind you of a couple things. There are actually 6 trig functions that you will be finding. You have your sine, your cosine, and your tangent, but you also have their inverses, cosecant, secant, and cotangent. Just remember that if you are finding sine, we'll do it the way we did in these previous problems. But if you want to find cosecant, you need to find 1 divided by sine. Or if you can find the answer for sine and then flip it, its inverse will be your answer for cosecant. Cosine and secant are inverses also. So to find secant, you will do 1 divided by cosine, or the inverse. Flip the answer of cosine. Tangent and cotangent. One of the things that you need to know, since the entire unit circle is given to you as cosine and sine, is that tangent is equal to sine divided by cosine. So cotangent is the inverse, which means we will flip this fraction, and it will be equal to cosine divided by sine. Let me do a tangent problem quickly, just to show you how this works. If I wanted to find the tangent of 60 degrees, I would take the answer for sine, square root of 3 divided by 2, and I would divide it by the answer for cosine, 1/2. When you're dividing a fraction by a fraction, you have a couple options. You could write this out as a division problem, and then you're going to notice that you can't divide fractions, so you will flip and multiply. And that's going to give you an answer of square root of 3 over 1. Or, if you notice in the original problem that both of your fractions have the same denominator, we know that denominator, once we flip and multiply, is going to cancel out. So you can do that cancellation right here, which gives me square root of 3 over 1. The 1 is unnecessary, and so my final answer is square root of 3. Now let's take a look at a couple of the problems that you're going to have on your homework tonight. The first thing that you are given is this blank unit circle. And we're going to start off by labeling those first 3 angles in quadrant 1, the ones that we just calculated. So let's connect our center to our side for our 30, our 45, and our 60-degree angles. For the 30, I'm going to write the 30 degrees out here, closer to the edge. 45 and 60. Now, each of these had coordinates. The 30, when we calculated it, the short side was the 1/2, and the short side is my y value. So it'll go here. The longer side was square root of 3 over 2. On the 45, both coordinates were the same, square root of 2 over 2 and square root of 2 over 2. If you remember, 60 had the same answers as 30, but they swapped places. So the x was 1/2 and the y was square root of 3 over 2. Now, let's go around. We're going to label these quadrantal angles that we have. We've got 0. As we progress counterclockwise, we'll have 90 degrees. And then we have 180 degrees, 270, and 360. The coordinates for these are easy because we know this is a unit circle, and so it goes 1 unit in each direction. So if we think about this as an XY axis, this first coordinate right here would just be 1 on the X and 0 on the Y. Up here, I would have 0, X, 1, Y. Over here would be -1, 0, and this one would be 0, -1. Now, one of the things that we haven't put onto our unit circle thus far is the radian measurements. And we talked about this last week, how to take degrees and change to radians. So I'm going to just refresh your memory on this. If I am given 30 degrees and I want to change that to radians, I'm going to multiply that by pi over 180. And I told y'all, don't put the pi into your calculator. Simply do 30 divided into 180. That's going to reduce to 1 over 6. And then put that with your pi measurement. So let me write this first one right here would be pi over 6. When I do 45 times pi over 180, I'm going to get pi over 4. And when I do 60 times pi over 180, I get pi over 3. All right, so as far as these coordinates, they are all 1/4 of your circle. So this would be 0. This would be pi over 2. So 1/2. This would be 2/2, which is the same as pi. 3/2. And this would be 4/2, which is the same as 2 pi. So now we've labeled everything with our degrees and with our radians and with our coordinates, which are going to give us our exact values for each of these expressions. So let's talk about how we use this unit circle to find these answers. There's actually one more thing that I need to label on your unit circle before we start into this, and that is, how do you know whether or not your answer is going to be positive or negative? Now, obviously, this is an XY axis, and you guys are very familiar with that your X values are positive here, your X values are negative here, and Y is negative down here, and Y is positive up here. But there's kind of an easy way to keep track of whether or not your sine or cosine or tangent are going to have a positive or negative answer. And we use a phrase, all students take classes. And so what does this stand for? This tells us what is positive in each of these quadrants. And if you remember, your quadrants are numbered 1, 2, 3, and 4. They're counterclockwise. So in this first quadrant, everything is positive, all of them. Sine, cosine, tangent, cotangent, cosecant, and secant. They're all positive. Here, sine is positive, and one of the things I want you to remind you of is if sine is positive, cosecant is also. So its inverse will be positive also. Down here, tangent is positive, which means cotangent is also positive. And then in this final quadrant, the only thing that is positive is cosine and its inverse, which is secant. So now that we have this labeled, we're going to use this to reference as we go through and answer these questions. And so I'll show you how we'll do a couple of these. In number 1, if we want to find the cosine of pi, first thing I want you to do is find pi on your unit circle. And you need to remember that cosine represents the x value at that location. So the x value is -1, and that is my answer. The tangent of 270. when we are calculating tangent, you need to remember that you have to do the sine answer divided by the cosine answer. So let's find 270. Here it is. And these are my coordinates. So the sine answer is -1 and the cosine answer is 0. Anytime you end up with 0 in the denominator, it is undefined. All right, let's do this one. Sine of 3 pi over 2. So here's 3 pi over 2, and the sine is the y value, so the answer is -1. All right, I'm going to do cosecant just to kind of remind you how to do an inverse. If I'm doing cosecant, that is the inverse of sine. So what I need to do is first find sine of pi over 2, and then I am going to find the inverse of that answer. Well, sine of pi over 2 is 1. The inverse of 1 is also 1. So cosecant of pi over 2 is 1. All right, let's look down here to some of these that are not quite so obvious. The first one that we have is the cosine of 31 pi over 3. Now, I think on bigger radians like these, it may be easiest to just convert it to a degree and then sketch that angle. If you do this conversion, if you take 31 pi over 3 and you want to change it to degrees, you would multiply by 180 over pi. The pi's are going to cancel, and you are going to get 1,860. Now, we know that if we're sketching this angle, every time we go around the circle, we have gone 360 degrees. So personally, I would look at this and see how many times I can go around this circle without going past this number. And just to kind of shortcut it for you, you actually can go around the circle 5 times. If you do 5 times 360, you're going to get 1,800. So I've got 1, 2, 3, 4, and 5. But I'm not done. I actually have to go 1,860. So I'm going to go 60 degrees more, and then I will draw my angle. Now, what you're going to do on all of these is you're going to find that reference angle. And the only 3 reference angles that you're going to have on this worksheet, they're either going to have an answer of 30, an answer of 45, or an answer of 60. We're going to use these reference angles to find our answer. So this particular one, if I'm wanting to know what triangle was created right here, this measurement is 60 degrees. So I'm going to focus on the 60-degree reference angle. Since I am trying to find cosine, I need the x value at 60 degrees, and that is 1/2. And that's my answer. All right, so what if it's not in quadrant 1? That was in quadrant 1. We can easily see it. Let's look at number 14. The sine of 300. This one I don't have to do a conversion on. I can go ahead and just sketch where this should be. So if I go 90, 180, 270, 300, I am right here. I have to identify this reference angle. Always measure yourself back to the x-axis, and so I am 60 degrees away from the x-axis, so that is what I'm going to focus on. I am down here in quadrant 4. You can see here. So I need to pay attention to which answers are positive and which ones are negative. Well, the only answers that are positive are cosine and secant, so my answer is going to be a negative answer. So how do I find out what that answer is? I want to identify what the sine of 60 is, and so I look up here. Sine of 60 would be the y value at 60, and that is square root of 3 over 2. let me do 2 more examples just to make sure that you've got the hang of this. What if we have to graph a negative angle? So just to remind you, negative just is talking about direction. And if I'm going negative 60, that means that I'm going this direction. As far as the reference, that's pretty easy. I traveled 60 degrees, so my reference angle is 60. I am down here in quadrant 4, which, if you remember, all students take classes, means that my answer is going to be a positive answer. So what I've got to figure out is what is the cosine of 60 degrees. So again, if you have to sketch it out so that you can, figure out what's what, just remember that the cosine is representing the short side, the side across from the 30. So this is my 1/2, and this is my square root of 3/2. So the cosine represents the x side of your triangle up here. So it is positive, and my answer is 1/2. Let's look at number 20, just because it does have a radian measurement. Just to kind of remind you one more time, if you're given negative 7 pi over 6, I would do the conversion. I would just change it back to a degree by multiplying 180 over pi. When you do that, pi's cancel, and you find that you are actually finding the value of the sine of negative 210. All right, so again, sketch out where is negative 210, right? Remember, negative refers to your direction, so you're going negative 90, negative 180, negative 210. And you need this reference angle, always the measurement between where you ended your terminal side and the x-axis. So this has a measurement of 30 degrees. All right, so will my answer be positive or negative? Think back, all students. Okay, everything up here is positive for your sines. Sorry, your y values are positive. So sine is positive, which means my answer is positive. I just need to figure out what is the sine of 30 degrees. So again, if you want to think back to those original triangles that we drew, you've got your 30 degree, and we know in this particular triangle, the y value is the short side, because my y is my up and down side, the height, and it is going to be positive. So the answer for this one is also positive 1/2.